Grit blasting. For better adhesion of sprayed material to the surface of base metal, proper surface preparation is required to provide a better anchoring effect of the deposited coating layer to the base metal surface. For this reason, grit blasting by bond particle should be done to make proper surface roughness with accompanying descaling. Arc spray. Arc spraying is a process that uses electric arc heat to melt wire-type coating materials and uses compressed air to spray melted materials. These are two types of arc spraying. One is single wire spraying, in which a wire becomes anode and the base metal becomes cathode. The other is twin wire arc spraying, which uses twin wires in that a wire becomes anode and the other becomes cathode. The two-wire approach with electric voltage and makes an electric arc within a short gap. The arc melts the wires and compressed air spray it to the target surface. This is one of the most general processes in the field because the apparatus is relatively simple, but it makes high productivity with the best safety. Flame spray. Flame spray coating utilizes combustible gases to create the energy necessary to melt the coating material. Combustion fuel gases include hydrogen, acetylene, propane, natural gas, etc. With the ability of flame spray to process wire, rod, powder, a wide variety of materials can be made into coatings. Even high melting point ceramic can be flame sprayed. Lower melting materials are also flame sprayed. Plasma spray. The plasma gun introduces inert gas and lets in pass through arc stream of nozzle. The inert gas grows to a high temperature plasma stream and coating powder is dropped into the plasma stream and is melted, and the melted powder wrapped by plasma flies to the targeted surface. The property plasma flame is small with high temperature, about to 10,000 degrees Celsius. A plasma flame can melt high temperature materials like ceramics and transfers less thermal effect to the base materials by the small heat capacity. HVOF. Coating powders are injected into a combustion chamber in which the mixture of fuel and oxygen grow high pressure flame, and the mixture of melted powder and flame pass through a supersonic nozzle and fly very fast and impinge to the targeted surface and makes high-density coatings with high bond strength. But it is not so good for field application because it has low productivity with unsafe properties. Cold spray. In cold spraying, particles are accelerated to very high speeds by the carrier gas forced through a converging, diverging, DeLaval-type nozzle. Upon impact, solid particles with sufficient kinetic energy deform plastically and bond mechanically to the substrate to form a coating. The critical velocity needed to form bonding depends on the material's properties, powder size, and temperature. Soft metals such as copper and aluminum are best suited for cold spraying. The coating of hard materials by cold spraying has been reported. Fusing. Thermal spray coating makes a lot of porosity in the coating layer with less bond strength essentially. The sequence process to improve sprayed coating layer is fusing. The fusing process makes remelting the coating layer by heating and results in less porosity with higher bond strength. This thermal process also has similar critical difficulties to hard facing.